In water, strong electrolytes separate into ions, positive and negative ions, making solutions that conduct electricity. So, if there was a solution, say sodium chloride, for example, there was a solute, sodium chloride, this is a strong electrolyte. Now, how do we know that it's a strong electrolyte? When you put it in water, it separates out to sodium ion and chloride ion. It ionizes to sodium and chloride ions. And when you put this solution in, when you put this in an electric field, say this is negative and this is positive field, these ions will orient themselves. So all the chlorides will go towards the negative and all the sodiums will go towards the positive. And so that's how these ions will be ionized by water. And this is a strong electrolyte. Weak electrolytes will produce fewer ions. So if you were to look for numbers, or if you were to look for some practical understandable example, say let's say HF, hydrogen fluoride, hydrofluoric acid, right? If you put this in water, this does ionize. It does ionize, but not to as great as an extent as sodium chloride. So sodium chloride is a strong electrolyte, whereas hydrofluoric acid is a weak electrolyte. So strong electrolyte and this is a weak electrolyte. Okay, now there are some substances in water, they do not produce ions. They just produce molecules. They are just molecules. Okay, they do dissolve, but they are non-electrolytes, so they do not conduct electricity. So if you consider a molecule like sucrose, this does not conduct electricity when dissolved in water. No electricity. So this is a non-electrolyte. So ionic compounds, 99% of the time, ionic compounds that dissolve in water are strong electrolytes, and some polar covalent compounds are weak electrolytes, and there are some molecules that are non-electrolytes.